Hello everyone, this is Charishma. Today I'll be explaining one of the most important algorithms in natural language processing, that is latent Dirichlet allocation, which is also known as LDA in short. I'll be explaining what it is, how it works, and also its applications. So let us start with the basic concept, that is topic modeling. Have you ever wondered how machines can automatically group thousands of articles or documents by theme without anyone labeling them first? So that ability comes from a class of algorithms called topic modeling. So topic modeling is an unsupervised machine learning technique that is used to find the hidden patterns or themes in a large collection of documents. So by the word unsupervised, we mean that it doesn't rely on any predefined categories or labeled data. For example, if we have thousands of news articles, the topic modeling can automatically group them into themes like sports or politics or education. So the common topic modeling algorithms include LSA, that is latent semantic analysis, or LDA, which is latent Dirichlet allocation. So this will be our focus for today. Here is a practical example. To make this concrete, imagine we have 1,000 news articles. So the articles that frequently contains the words like player or goal or match are likely to be about sports, and the articles with the words like minister or a vote or election are likely to be about politics, and also the articles with the words like student or exam or school are likely about education. So although the computer doesn't really understand the meaning, it detects the statistical patterns of word usage, like, and then it groups those documents together. And that is the practical power of topic modeling. So let us build some intuition. So LDA assumes that each document is a mixture of several topics, and also each topic is a mixture of several words. For example, uh, the topic sports might contain the words like match or player or goal, and the topic politics might contain the words like minister or vote or elections, and the topic education might include student or exam or school. So if a document contains words like student and goal, it may be partly about education and partly about sports. Here is how LDA imagines the documents are created. So for each documents, it chooses a topic distribution. For example, 50% sports or 30% politics and 20% education, etc. And then for each word in that document, it randomly picks a topic based on the distribution, and it choose a word from that topic's vocabulary. After generating all the topics this way, LDA works in reverse. So it looks at the words and infers what the hidden topic structure must have been. The output of LDA gives us the document topic distribution, a list of how much each topic contributes to a document. For example, a document might contain 80% about sports, 15% about politics, and 20% and 5% about movies. Or another document might contain a majority about politics, that is 85%, or another topic might contain mostly about movies and partly about sports and politics. So this mixed representation is much more realistic than assigning just one label, and because the most real world documents covers the multiple ideas. LDA is a graphical model. We can conceptually understand this as three connected levels, that is, documents, topics, and words. each document has a topic vector, that is how much each topic appears in each document, and each topic has a word vector, that is a set of words, like how likely each word is under that topic. And LDA learns these distributions by looking at the word occurrences across the documents. So in plain language, documents pick topics and topics pick words. So this conceptual structure explains why the document topic table we just saw in the previous slide makes sense. Here comes the probability model of LDA. LDA refines the topic assignments using two key probability calculations. The first one is the probability of topic K in document D, and the second one is the probability of word W given the topic K. Here, NDK is how many words in document D are currently assigned to the topic K, and NKW is how many times the word the word W is assigned to topic K. And K is the number of topics, V is the size of the vocabulary, and here the alpha and beta are the smoothing parameters. We'll be looking into these smoothing parameters later during the tuning process. So these formulas are used repeatedly to update the assignments until they stabilize. So these probabilities are the engine that moves LDA from random assignments to meaningful topics. Uh, so, LDA is an iterative refinement process. So, putting it all together, LDA learns through iteration. In the first step is it assigns the topics randomly to each word, and then it computes the probabilities for each possible topic using the formulas that we saw in the probability model of LDA slide, and then it reassign each word to the most probable topic, and then this will be repeated until the changes are small and the distributions converge. And after convergence, we obtain two useful outputs. The first one is the topic word distributions, which words define which topics, and then the document topic distribution. This says how much each topic appears in each document. So this iterative refinement converts the noisy initial guesses into stable interpretable topics. uh, Here comes the applications of LDA. LDA is widely used where the large text collections need summarizing, and it cannot be done by the humans. The first one is the news article categorization, which we saw in the previous slides. It includes the like grouping of articles automatically, and then the research paper clustering. Um, Here it is used, LDA is used to find the research themes, etc. And customer feedback analysis. Here it is used for extracting common complaints or praises, etc. And recommendation systems. Here matching the content by underlying topics, etc. And the search and information retrieval, it is for better query understanding. So whenever manual reading is infeasible, latent Dirichlet allocation helps us summarize and structure that content. So to get useful topics, LDA requires tuning. So the important parameters for tuning are the number of topics. How many topics the model should find. If the topics are too few, then there will be broad categorization of topics. And if the topics are too many, then it will be noisy and overlapping of topics might happen. Then alpha, alpha and beta are the smoothing parameters. It like alpha controls how many topics appear per document. If the alpha value is too high, documents are a mixture of many topics, and if the alpha value is too low, then the document concentrates on fewer topics. And for the beta value, uh, it controls many words. It controls how many words appear per topic. If the beta value is too high, then topics use many common words. And if the beta value is too low, topics are more specific. Then passes, which are also called as iterations. More passes let the model refine further, but it might take longer. So, careful tuning improves coherence and also better interpretability of topics. Visualizing the latent Dirichlet allocation output. So, two practical ways to present LDA results are word clouds and bar graphs. Word clouds for each topic say shows the in word clouds for each topic, larger words indicate higher importance, and bar chart shows the topic proportions for each document, and top n word list for each topic to read and interpret. So these visualizations turn the abstract probabilities into intuitive summaries, and which the humans can interpret. And we can use them to validate whether topics make sense. Moving on to advantages and limitations. Firstly, advantages. It is fully unsupervised. That means that no label data is required, and also it discovers the hidden structure in the text, and also it scales to large corpora. That means it works on large data sets. And coming to limitations, it is sensitive to parameter choices, so we need to choose them wisely. And also, it is less effective on very short text, for example, single tweets, etc. And also, it can be computationally heavy for huge corpora. So, LDA is powerful but must be used thoughtfully. uh, it requires using with good parameter tuning, and also we must keep realistic expectations. So in summary, latent Dirichlet allocation is a probabilistic model that represents the documents as mixtures of topics and topics as mixtures of words. Through iterative probability updates, it uncovers the latent thematic structure of large text collections. Thank you for listening.